Hello everyone. In today's session we are going to discuss the binomial theorem to expand the binomial expression. So with me here I have an example that we are going to discuss, that is using the binomial theorem expand the binomial expression, that is 3x plus y raised to power 6 in ascending powers of x. And we know for us to be able to use, we can use the Pascal's triangle, we can also use the binomial theorem, but in this question is specific on the binomial theorem. And we know that the binomial theorem, maybe for example, if we are given the values of a plus b, a plus b, a plus b, then we have to expand raised to power n. So if we have a plus b raised to power n, this one, if we use the binomial theorem, this one is supposed to give us the summation of n, then k, which is equals to 0 for the initial value of k. Then we have here we have these factors nk, and then we have a, we can have a raised to power n minus k, and then we have b raised to power k. So that is how we can apply the binomial theorem. And we know, maybe for example, when we are given maybe a value like maybe for example we are given a value like maybe 6 0, this one we know that we can get this factor by saying this one is the same as 6 factorial and divided by 0 factorial, then multiplied by 6 maybe minus 0 factorial. And remember, this one will give us the 6 factorial divided by 6 factorial multiplied by 0 factorial. So remember, this and this cancel, so we are left with 1, because 0 factorial is the same as 1. So that is what we are going to apply using this to get the binomial theorem. So we know for our case in x ascending, here we are going to have the first one, which is we get 6, then combination of 0, then we have 3x, this one is raised to power 0, then we have y raised to power 6, then plus the second value will be 6 combination 1, then we have 3x raised to power 1, and then we have y raised to power 5, and then the second one will be plus 6 combination 2, then we have 3x raised to power 2, then y raised to power 4, and then the other one will be plus 6 combination 3, then we have 3x raised to power 3, then we have 3 y raised to power 3, and then plus the other one will be 6 combination 4, then we have 3x raised to power 4, then we have y squared, then plus the other one will be 6, then combination 6, then combination 5, we are in combination 3, combination 5, then we have 3x, 3 multiplied by 3x raised to power 5, and then we have y raised to power 1, then plus the last one is 6 combination 6, then we have 3x raised to power 6, and then y raised to power 0. So that is how we can use the binomial theorem to expand that. We can expand this. We know that 6 combination 1. 6 combination 0 is 1. Then 3x raised to power 0, that is 1. Any number raised to power 0 is equals to 1. Then we have y raised to power 6, then plus we have 6 combination 1. If you do it with your calculator, 6 combination 1 gives us a 6. Then 3x raised to power 1, still we get 8 being 3x. Then we have here y raised to power 5, and then plus the second value we have 6 combination 2, and the 6 combination 2 will give us a 15. Then we have 3 squared is a 9. 3 squared is a 9, so we are going to have 9x squared, 9x squared, then plus the other one we have 6 combination 3, and this one will give us a 20. Then 3 raised to power 3 is a 27, x cubed. Then here we have, so here was y raised to power 4, so here we have y raised to power 3, then plus 6 combination 4 becomes a 15. Then we have 3 raised to power 4 becomes 81, x raised to power 4. Then these we multiply by y squared, then plus we have 6 combination 4, this one is a 6, then 3 raised to power 5, this one is 243, x raised to power 5. Then we have all these we multiply by y, and then the last one we have plus 6 combination 6 is a 1, and then this one we multiply by 3 raised to power 6 is the same as 729, x raised to power 6, So now we can remove the brackets, or we can work out the first operation. We have 1 multiplied by 1 multiplied by y raised to power 6, and this one becomes y raised to power, this one becomes y raised to power 6, then plus the other one becomes we have 6 multiplied by 3 becomes 18x, then y raised to power 5, and then we have plus 15 multiplied by 9, this one becomes 135, x squared y raised to power 4, then plus the other one becomes 20 multiplied by 27, this one becomes 540, x cubed y cubed, and then plus we have the other one is 15 multiplied by 81, which becomes 1458, x raised to power 5, then y, and then plus the last one, which becomes 729, x raised to power 6. So that is how you can expand any binomial expression using the binomial theorem. So next, let us try to solve or to evaluate any numerical value after. So, and in this case we are going to solve for 15.1 raised to power 6. So the first thing, we can just equate the two. So we have 3x plus y raised to power 6 is equals to 15.1, because we are going to solve the same numerical value, so we can cancel out the powers or the indices. So we shall be left with the 3x then plus y is equals to 15.1. And for us, the interest is to get away with these unknowns. So the first thing that we can do here, we can sprint the decimal part so that we have 3x plus y is equals to 15, then plus 0.1. So we can say that our value of y will be equivalent to 0, will be equivalent to 0.1, and then we have 3x is equivalent to 15. So you can say that our x will be equivalent to 5. So now these values that we have for x and y, we can come and substitute them in the equation that we expanded. Remember, the value of y is 0.1, so the first one will be 0.1 raised to power 6, then we have plus, the second one is 18x, and remember x is 5, and then y is 0.1, and this one we are raising it to power 5, then plus the second one is 135, then here we have 5 squared, then we have 0.1 raised to power 4, and then plus we have the other one which is 540, then we have 5 raised to power 3, then with this one we are multiplying with 0.1 raised to power 3, and then plus the other one is 1215, then this one we multiply by 5 raised to power 4, then multiply by 0.1 raised to power 2, and then plus the other one is 1458, and then this one is 5 raised to power 5, and then multiplied by 0.1, and then plus the last one we can have 729 multiplied by 5 raised to power 6. And if we output all these using our calculator, we are going to have 853,911.59, which will be just the same value if you take using your calculator 15.1 raised to power 6. And that's how you can solve any binomial expansion and evaluate any numerical value using the expressed binomial expansion. That brings us to the end of this session. I was your trainer, Maurice Murine. If you have found this video of benefit to you, consider subscribing, like, and share it to many platforms so that it can reach many to have the same knowledge. Thank you.